You do round 2, problem number 2. Write an equation of the perpendicular bisector, so perpendicular, so we're going to change the slope, bisector, so we're going to pass through the midpoint of the other line. In slope-intercept form, mx plus b, of the line segment whose endpoints are 8, 2 and 0, 6, a, b. Okay, so there's the line that we're going to do the perpendicular bisector for. So what slope do we have here? We have a move down, 1, 2, 3, 4, and a move to the right, 1, 2, 3, 4, 5, 6, 7, 8. Down 4, right 8. So there's the slope of AB, down 4, right 8. That's -1/2. So then my perpendicular slope will switch 1/2 to its reciprocal, 2, and switch the sign from negative to positive. So now we have to make sure we go through the midpoint. So to find the midpoint of AB, we'll use the x values 8 and 0. So 8 plus 0 divided by 2 is 4. We use the y values 2 and 6. 2 plus 6 divided by 2 is also 4. Don't be tricked. It's not always 4 and 4. That's just how these numbers came out. So we need to pass through the point 4, 4, where we're talking about right 4 and up 4. So the equation of our bisector is y equals slope of 2 times x minus 4 in parentheses plus 4. Great job, Smarty Pants. Let's keep it moving. Number 3. Okay, number 3 talks about a square. Square ABCD, where A is at 1, 0, B is at -1, -4, C is at -5, -2, and D is -3, 2. So it looks like this. You can see I made a couple of mistakes the first time that I went to plot these points. So plot them carefully. 1, 0 is A, -1, -4, B, -5, -2, C, and D. Okay, so the question, write the equation of the perpendicular bisector of CB. So again, we need the slope of CB, down 2, right 4. So that's a slope of -1/2. Now, we need to pass through the midpoint of CB, which it looks like is right here. But let's just calculate that real quick. So that's here. So for the x value, we have x at -5 and x at -1. So we add those together and divide by 2 and get an x value of -3. And then for the y value, we're looking at y equal -2 for C and y equal -4 for B. So again, add those and divide by 2. -6 divided by 2, -3. Again, it's a coincidence that these are the same. So this tells us that we want a slope of from -1/2 to +2. And we need to go through the coordinate that is left 3 and down 3. So that's parentheses x plus 3. And then down 3 minus 3. Here this is in point slope form. Now we put it in slope intercept form by distributing 2 times x plus 3 and getting 2x plus 6. And then minus the 3 from the outside gives us y equals 2x plus 3. Problem number 4. The endpoints of a segment are 5 comma 5 and negative 7 comma 1. And in this case there's no diagram, so we need to draw a diagram. And the line does not have a name, so I'm calling this line L. And there's a quick diagram, not the most beautiful, but you see negative 7, 1 as one endpoint and 5 comma 5 as the other endpoint. Again, we're being asked to do the perpendicular bisector of this, even though in the problem they forgot to ask it. So we gotta find the slope. So this is a move up 4 units, from 1 to 5 up 4, and a move right from negative 7 to 5, so that's right 12 units. Up 4 and right 12 gives us a slope of positive 1/3. The perpendicular slope will be negative 3. Take 1 over 3 and give the reciprocal 3 over 1. Change the sign from positive to negative 3. Oh, so I didn't finish this problem yet. Let's do it now. I'm just going to do it in point, well no, I'll do point slope and slope intercept, that's fine. So we'll call this line P. And for line P we have y equals slope of negative 3 times, and we'll just use one of these coordinates. I'll use this 5 comma 5 coordinate. So that's x minus 5 because of right 5, and then plus 5 because of up 5. There it is in point slope form. Now to put it in slope intercept form, we'll distribute the negative 3 to the parentheses. So we have negative 3 times x. Then negative times negative is positive. So plus 15 and then plus 5. So then to simplify this, we're looking at negative 3x plus 20. And that gives us the answer in slope intercept form. Great job, smarty pants. Keep using perpendicular slopes. Please keep finding the midpoint. Oh, sorry, we have to read this explanation down at the bottom. I forgot about that. Okay, so the question, does the perpendicular bisector of the segment have a positive or negative slope? Explain. So we'll say the slope of the perpendicular bisector is negative because the slope of the original line is positive. And for perpendicular line, we have to change the sign, change to the opposite sign in the slope.